Cool. Okay, so last class we kind of talked about a basic introduction. We talked about, how to initialize a variable. We talked about a little bit about casting. We talked about how to print out to the console. This is the console, by the way. We talked about basically just some of the introductory ideas in Java. Now we're gonna be looking more into identifiers and naming conventions, and we're also gonna explain like some other data types and the storage, which I did mention last class, but I'll reiterate it. And control flow. This is the main part of this lecture. Control flow. Make sure you remember that. Control flow is basically one of the essentials to any programming language and essentials to any sort of computer science concept. So first we'll talk about identifiers. So when I say identifiers, I mean like the names of variables, methods, classes, packages, interfaces. Don't worry about the last four right now. Just think about variables. So wait, it's loading for a second. Okay, so if I want to define a variable, let's say I call this variable like int x equals 5. In this case, my identifier is 5. So the identifier is x. Sorry, my identifier is x, okay? And you can change the value of your identifier, like I mentioned. I can say x equals 6. Now, just one thing to note, when you have an identifier, you want to make sure that it's descriptive. So in this case, there's no context, so I guess it doesn't have to be descriptive, but let's say you're designing a amusement park, right? You don't want to call the number of roller coasters x. You want to call it something like num roller coasters, right? So you want your variable names to be descriptive, and you want them to, be readable, basically. Like if somebody else looks at your code, if they see x, they might not know what x is, but if you give it an actual name, it'll be clear in their eyes what they're dealing with, and it'll make the program more readable, right? Because ultimately, it might compile, it might work, it might produce the desired output, but if someone were to reproduce your code or look at it, they might be in dire straits. So let's look at the next part. Yeah, so identifiers do have naming conventions, so all identifiers should begin with a letter, currency character, and underscore. Like, I haven't really seen identifiers begin with a currency character. That does exist, I know. I know there's like some in like the terminal in the command prompt. This is how you actually like write variables using the currency character. But I haven't seen this used too often in Java. Mostly just gonna be like A to Z, lowercase a to Z, and underscore. One thing to keep in mind is that Java uses camel case, meaning that let's say I have num roller coasters. It's gonna look like num roller coasters, right? The first letter is lowercase, the second letter is capital. In other languages, you might see the convention being like num underscore roller coasters. Both are fine, honestly, but in Java it's preferred to use camel case, which is when the first letter is a lowercase. So I'm gonna write that down. So camel case is when first letter lowercase, second letter uppercase. Cool. Are there any questions so far? Or okay, we can move on. So after the first character, identifiers can have any combination of characters. A keyword cannot be used as an identifier. So basically, keywords are like the things in blue, like I talked about last time. So you can't have like something like static. You can't have void as a variable. So I can't go ahead and say, I'm designing a physics simulation, and I have some parts that don't move, and I want to make those parts called static. So I'm going to say, okay, string static equals not moving parts. This is not allowed in Java because what happens is it confounds the keyword static with the thing you're trying to name called static. Like you can't call something a keyword basically. So I can't call this like string public, or I can't call this like string void. Those are reserved words in Java, and you want to stray away from using those as your identifiers. Let's keep going. Yeah, so identifiers are case sensitive, so that means so I'll write that case sensitive, which means that you know, they uh, um, capitalization is important, right? And that makes sense, right? If it's case sensitive, that means you have more combinations of identifiers you can come up with, right? Um, there are certain naming conventions you follow in Java. The first letter of a class, yeah, so this is capital, basically, camel case, basically, like toString, yeah. Yeah, so there are illegal identifiers. You can't have any spaces in your identifiers. You can't begin with a digit. You can't have a plus sign. Uh, yeah, there's basically a bunch of rules that you can't use, but just when you're dealing with this, don't worry about memorizing the rules too much. Just pretty much just use common sense. Just don't do anything weird or crazy. Just you know, and the compiler will tell you anyway, so it's gonna be pretty easy to figure out. Cool. Now we're gonna be talking about data types, which I think I talked about in last class, but here's something I didn't really mention. You can use like a letter after the after your value and turn it into the data type of that you're assigning it to. So I'll give you an example. So okay, so now we're gonna move on to like a little bit about data types. So you guys already know in I equals 0, but let's say I want to do float f equals 5f, right? And let me do system.out.println f. Let's see what this prints out, right? It prints out 5.0. So basically this f, it turns it into a float. Let me give you guys a trick question. I want to see if you guys can do it. Okay, tell me what you guys think this will print out. Wait, system.out.println f. Tell me what you guys think that will print out. Oh yeah, I'm in the basement right now, so my Wi-Fi might be going like up and down. Sorry about that, Jasmine. Do you guys have any guesses on what this could print out right here? What f? It's okay if it's wrong. I'm just curious, like what y'all think mostly. No guesses? Okay, Urban's typing. One 1.66 and 5 and 3. Okay, he said 1.333-ish. Well, I think that's more of a computational thing, but we can kind of check it out. So let's see what it tells us. So yeah, it is indeed 1.666 because remember, I talked about it last class how the only weird case is integer division. Everything else works just fine, and this is a case of if any one of the two operands are floating point values, then by default it's going to yield the right value, which is indeed 1.66666. Cool. Okay. You can do the same thing with doubles. You can suffix it with the d. Booleans, we talked about that. It's either true or false, right? It holds 1 bit. Cards take up 2 bytes of memory. Doubles take up 8 bytes of memory. Yeah, and depending on their memory allocation, they have varying degrees of precision. Like doubles have a lot of precision, which means they can hold a lot of decimal places, while floats have less precision, so they can't have that much. They don't hold that many decimal places. Does anyone have any questions so far, or is everyone is everyone understanding it? Okay. Oh yeah, Cappy, I recognize you from last lecture. Let's see if I recognize anybody else. I think I recognize Oatmeal Man, and I don't recognize anybody else from last lecture. Yeah, I think I remember Beans a Cornbread. I think he came. When's the right time to use a float over a double? Just never do it, basically. I don't know what else to tell you. Just use doubles. like if your teacher tells you use it. But this doubles have more. Unless you have like you're using like a like a really old, I don't know, like a small PC that can't handle that much memory. If you're like Grace Hopper, and you want to optimize something. But other than that, see doubles is much easier. Okay, some people are typing. Let's see what questions they have. There are only a few cases where things are defined. Yeah, exactly. Yeah, that's exactly right. Okay, I'll keep going. So now we're gonna move on to something called ControlFlow. I hope you guys understood everything so far, because if you didn't, it'll be a hard time grasping these concepts basically. And these concepts are pretty much important for the rest of this course. I am getting errors when I put this. All right, show me the code. ME. I'll take a look at it, and I'll show it in class, and we can talk about why you're getting what wrong. I'll make sure he sees this. Oh, he said he fixed it. Okay, cool. You can share your error on the group chat so we can all learn from it. It helps everybody. I cannot see your screen. I'll post the recording after class. Shouldn't be an issue. I can send it to you. Cool. All right, I'm gonna keep going. So in Java, we have something. In all languages, we have something called ControlFlow. So this is a really big topic, ControlFlow. And ControlFlow is this kind of reminds me of a lot of things. So in programming, statements get executed from top to bottom, and I want you to remember that. So I'll write that down. So typically, statements get executed from top to bottom. However, a lot of times we might want to do things a little bit differently, right? We might want to control that flow. Does that make sense? Or like you want to control your flow, right? Because some typically, like if I say system.out.println, or no, shoot, system.out.println neo, and I have system.out.println Sandel, and I have system.out.println Bob. So how does the compiler look at this? Wait, somebody send me messages. Yoshi, I cannot see your screen. Well, I don't really know how to help you with that. You could probably try closing Discord, opening Discord, joining my stream, and seeing if it works. So just those are the only troubleshooting techniques I know, to be honest. Yeah, anyway, so how it works is it'll go line by line. So this normal control flow is line by line execution. I want you to remember that. Normal control flow is line by line execution. Does that make sense? Like you're going line 20, line 21, line 22. Like how does this work? Line 13, line 14, line 15, line 1, line 2, right? That's how it works, right? Okay, so we see it prints out Neil, Sandel, Bob, right? Cool. Now, oh wait, somebody told me not to delete it. Okay. So now, I think it's a bit confusing with all the noise. Lecture notes will be posted afterwards. Okay. Okay, so now we want a way to hijack, right? We want a way to hijack normal control flow. And how can we do that? We can use something called control structures, right? So first, I'll give you a bit of an overview. We'll talk about for loops. I think in this session we're going to talk about while loops. I'll just talk about it anyway. We'll talk about while loops. Next, we'll talk about switch statements. I think this is all we'll get to for today. But first I'm going to talk a little bit about the main method in Java, because I think that's important to talk about. So the main method in Java also kind of hijacks normal control flow because the program starts executing here. So regardless of if you have other lines in other program or other files, it's going to start executing at the main method. So I'm going to use that analogy in switch statements as well. This will help me understand it. So main method analogy, I guess. Okay. So let's first talk about for loops. Okay, cool. And I have a few exercises I want you all to do to make sure you understand it. Before for loops, I want to talk about if-else statements. I'll make it number 0, indexing it from 0 like a true computer scientist. If else statement. This is not a loop, by the way. I hear people calling it if loop. It's not an if loop. So everyone says, oh, programming can be used to solve the world's problems. It can be used to, have an impact on the world. And you're like, I'm learning about integers and booleans. I can't really see how I can solve the world issues. But don't worry, if-else statements come to the rescue. So pretend you're deciding whether to wear your raincoat today, or to wear a jacket today or not wear a jacket today, okay? You're really confused, and you tell yourself, I'm a computer programmer, I can think of a way to do it. So you define a variable called temperature, and let's set this to like 50, right? And you say, if, or let's just say you don't set this to anything at all. And I'm gonna do something here, but don't worry about it, okay? I'm gonna do something like a little extra thing here, but I'm just doing it for the sake of example. All I'm doing is taking in user input. I'll explain later. Don't worry. This is basically I'm taking input from the console, from the user. So you're gonna ask yourself. You're gonna say, Neil. This is just for the sake of example, so don't worry if you don't really understand it. Neil, what is the temperature today? That's your smart home device asking you what the temperature is. And then you're going to answer it. So you're going to say temperature equals scan.next integer. And then you're going to say if this temperature is greater than 50, no. If it's less than or equal to 50, I want to print out wear a jacket. Otherwise, I'll explain all this in a second, don't worry. Otherwise, I'll print out no need to wear a jacket. Cool. So basically, I'll start from the beginning. So first, we initialize a variable called temperature because this, the value of this variable is going to be the basis for our control flow. Essentially, it's going to be the basis for deciding whether we want to wear a jacket or whether we don't want to wear a jacket. If the temperature is below or equal to 50, that means it's going to be really cold, aka we want to wear a jacket. In all other cases, else, these are two mutually exclusive cases. Mutually exclusive meaning if one happens, the other does not happen. We don't need to wear a jacket. So what happened is I set up a way to collect user input. This is how I collected user input, and I compared it with the value of 50. So what happens? It's saying if this temperature is less than or equal to 50, I do something. Otherwise, it's going to do something else. Now here's the important distinction from normal control flow. If this was normal control flow, both statements would have printed. It would have printed wear a jacket and no need to wear a jacket. But what the deal is that what do you call it? In this case, we're doing one or the other depending on this condition. So if the temperature is less than or equal to 50, it's going to print wear a jacket. If the temperature is like 70 per se, it's going to print out no need to wear a jacket. So let's try this out. So I'm going to run it. Neil, what is the temperature today? If I say 49, it says wear a jacket. Now let's try another one. Neil, what is the temperature today? If I say 82, it says no need to wear a jacket. So that's like a basic if-else statement. I think this is kind of where people start to like it a little bit more. Yeah, cool. So I'm going to talk about for loops now. Somebody tag me. Okay. Okay, let me see. Can you pause for a minute, then I can copy code? Yeah, for sure, my bad. Here, I'll give you guys a few seconds to like copy it down or whatever. I can even screenshot it if you want. Let me know when you're done, Oatmeal Man. Do you guys have any questions, by the way? Like, does anybody have, okay, cool. If nobody has any questions, I'll just keep going. Cool. So now let's talk a little bit about for loops. So for loops are basically like, so pretend I want to loop through, pretend I want to repeat, right? So when you're doing normal control flow, you can only do things once, right? So if I want to print out Neil once, I can only do it once. If I want to do it again, I have to copy paste this entire statement. I have to do it again and again and again and again and again, right? Pretend your boss says, "Hey, I want you to, I want you to print my name 200 times," just because your boss is egotistical. Can you pause? What do you mean by that? Pause. Emmy. Am I going too fast for you? I still need to copy the code. Alright, that's cool. Here, let me screenshot it for you. There we go. Okay, so for loops will code a bunch of times. So, if I want to print out a statement, Neo, 10 times, it's really tedious for me to go and, Control C, Control V, Control V, Control V. And I know a lot of you guys are experts on that, right? Control C, Control V, but frankly, computers allow us to do things in easier ways. So we're going to introduce a control structure called for loops. So I'm going to first show you the skeleton code of a for loop, and then I'll explain it. So don't worry if nothing makes sense right now. So your boss said you want to print out like 50 times, right? And so we're going to do system.out.println boss's name. Okay, let's see what this tells us. Oh wait, whoops, I need to do something. Okay, let's actually do a funny scenario. So you wake up in the morning and you want to know the temperature today. Temperature is 48, so you wear a jacket, and then you print out your boss's name 50 times. Isn't that pretty cool? Yeah, so someone tagged me somewhere. Okay, and then, cool, so let me explain what's going on in the under the hood, kind of. Or it's not really that under the hood, it's essential for understanding for loops. So the first thing that happens is your variable gets initialized. So first, we have the initialization stage, right? It says int I equals 0. Okay. Second, we so after it initializes the variable, I think there should be some helpful diagrams here. Hold on. I like thinking of things in terms of diagrams, so it really helps me. Okay, I don't know where the diagram went, but I can go ahead and explain it. So second, the value of the variable I is checked against the condition, which in this case is I is less than 50. So it says, hey, I'm 0. It says 0 is less than 50, true, and then it prints out Bob's name. So let me walk through that on a much smaller scale. Cool. Let's see what happens here. Okay, so it prints it out once. So let's try to understand. So first, int I equals 0. So keep that in your mind. The value of I is 0. It checks 0 is less than 1. True. If it's true, it prints this out, and it increments the value of I by 1. I is equal to 1. Is 1 less than 1? Nope, it's not true. So the for loop execution terminates. Well, that's the basic idea. It'll take a while to get a hang of things, but just remember that just remember like little triangles. So after you first it starts from it goes condition, body, increment, condition, body, increment, condition, body, increment, like that. So just remember that. Just remember it checks the condition, it executes the body, it increments. Checks the condition, executes the body, increments. Okay, that's like what I want to remember. So remember, checks the counter variable, which is I. It executes the body, which is in this case printing out, and it increments the counter variable. So I'll give you guys a little exercise. So try printing out, use the for loop to print out your name 5 times and post the code in the Discord server. Hold on. Yeah. Okay. Yeah, so you can do anything you want with I++. It's just like I use I++ because I wanted to print it out a certain number of times. Oatmeal Man said, I'm still on the jacket thing. Okay, what are your questions on the jacket thing, Oatmeal Man? Yeah, so I'll talk about the enhanced for loop a little bit later. My code keeps going wonky, so paste the code in the channel and I'll show you what's wrong. Okay, classmate posted void main, and temperatures can use as well. Oh, you forgot a semicolon, Oatmeal Man. You forgot a semicolon after both of your print line statements. Actually, all of your print line statements. So you might want to try that. I don't know if you heard that, but yeah, I made that mistake too. Don't worry about it. So I'm pretty I'm guilty of that as well. Okay, is everyone clear? Like so what is it saying the error is? So you forgot brackets after your else. You want you want the right brackets, right? Java uses a lot of brackets, so you want everything to be symmetrical. If you open a black bracket, you close a bracket. Yeah. There's no semicolon in a for loop. Only in the body of the for loop you want a semicolon. Exactly. That's a good distinction. Thanks for pointing that out. I didn't think about that in if you're new to it. Cool. So does anybody want to do the exercise of printing out their name 5 times? Yeah, it should be a. I mean, it can be a capital I if you want it to be. You just have to be consistent. Yep. Cappy got it right, but I think you should take out the last 2 brackets, Cappy. Like because you didn't include the other things in. Yeah. Yeah, yeah. Yeah, I know Cappy, but just yeah, just being a little bit semantic. All right, cool. Okay, cool. I guess only one person wanted to do it. That's okay. We'll move on to, or did anybody? I think you will have some more questions. I'll just wait for like a couple more minutes, and we can talk some more about for loops because those are pretty important. It's still having errors. Just post the code, dude. Yeah. And also tell us which line it's giving the error. It's scan.next int, not scan.next in. So you know, that's an error. And also one thing to know is when your code isn't working, try to like debug it a little bit yourself. Like try to you know, try to find these things. Because typically your compiler will tell you exactly what line it's on, and then yeah. It's okay. I made the same mistakes a lot too, so okay. Yeah, Cool. I think I'll move on to some more for loop examples. So, I think in one of the examples here, they ask you to print out task 2.3, print out the following pattern. So, I want you guys to try printing out this pattern. This is a true test of whether you have logical thinking and whether you can use for loops. So, I'll put in the chat, and first one to finish this challenge gets a cookie. Okay. Oh wait, it's not supposed to look like that. I'm sorry. Delete message. Okay. Yeah, first one to finish this challenge gets some kind of prize. Okay. I'll give you a hint. Use the value of the counter variable to print out the corresponding number of stars. Also, you'll also need to distinguish between system.out.print and system.out.println. Those are my two hints. So I'll just write that in the chat. So you'll need to use this to print out the number of stars on each row, and the second one to print out the number of stars to go to the next line, basically. Actually, you know what? I'll just do this one. Actually, I'll do this one, and then you guys can do the next few, because it's kind of hard to think about it at first. So basically, I want to first set up my for loop to the number of rows. So in this case, there's 5. Actually, no, I want to start it at 1, because my first star is 1, and I have 5 stars in my last row. So I is less than or equal to 5, right? Because I want to include 5, and then I++, and then, oh wait, whoops, wrong bracket. And then, on every single iteration, I want to print out one of these, right? So first, and then after I finish doing this, I want to do a print line, basically. So what you can do, I think it's a bit too advanced right now. You have to do something called nested for loops, which I don't think I want to get into. So let's do an easier. Actually, I think it's necessary kind of to do nested for loops. I don't know if you guys want to do nested for loops. Do you guys want to do nested for loops this class, or we can do it another time if you want to? Yeah. Oh, really? Okay, I think we'll go over it then. So basically, the outer for loop. So I'll give you a little bit a short example. So I is less than 5. So this is an example of a nested for loop. This doesn't relate to the question, by the way. This is just an example. So this is an example of a nested for loop, and in nested for loops, you have 2 counters. You have your outer counter and you have your inner counter. And basically what happens is the outer loop runs 5 times, the inner loop runs 4 times, right? Because for 0, for 1, for 2, for 3, for 4, for 0, for 1, for 2, for 3, for 4. And you can use the values of these counters to do pretty cool things. So I'll start with a kind of introductory example of what you can do with the counters. So let's say my mom asked me to print, I don't know why my mom, but my mom asked me to print all the numbers from 1 to 5, from 1 to 10. Here's what I can say, I know a tool for that. I can use a for loop. So you do I++, and you do system.out.println I, right? See what this prints out. Okay. So yeah, see, it prints out all the numbers from 1 to 10. Now pretend my mom is like, I don't really want you to print all the numbers in a vertical line. I want you to print a horizontal line. You say, okay, I know another tool. The tool is system.out.print that doesn't create a new line. And I also want to create a bit of space in between each of these characters. So I'm going to do something like this. And let's see what this gives us. Cool, it prints all of them across. And notice how our pointer didn't go to a new line. It's still on the same line. Nice. So what's happening here is you initialize it to 1. It checks, is 1 less than or equal to 10? It is indeed. So it prints it out. It increments it, you get 2. It checks if 2 is less than or equal to 10? It is indeed. So it prints out 2. Increments 3. Is 3 less than 10? It prints out 3. And then you get 4. Is 4 less than or equal to 10? It is. So it prints out 4. Do you guys get where I'm going here? So that's the logic behind loops. Yeah, cool. So I'm gonna talk a little bit about I'm gonna wait for some questions because I don't want you guys to get all lost. So tell me if you guys have any questions before I move on. Yeah, it's print ln, not print in. Yeah, let's not use a bad language in the server. But yeah, I can understand your frustration. Yeah, Cappy, I got you. So now I hope you guys kind of understand the logic behind using the counter variable to do something. In this case, we just printed it out. So now I want to show you the logic behind using two nested for loops, right? So here's how I think of it. I think of it as for every single iteration of the outer for loop, you do the inner for loop that many number of times. So here's how I think of it. So when I is equal to 0, you do j equals 0, j equals 1, j equals 2, j equals 3, j equals 4, j equals 4, right? When I equals 1, you do j equals 0, j equals 1, right? So on. I don't know if that makes sense, but this is how you're supposed to look at it, basically. So let me copy that. When I equals 2, when I equals 3, and when I equals 4. So do you guys kind of see what's happening here? So let me make this a little bit nicer looking. Okay, cool. This is what's happening basically. So on every single iteration of the outer loop, you're executing the inner loop. You're executing the inner loop to completion. Does that kind of make sense? Completely lost. We'll have to rewatch. Yeah, for loops are really confusing, but I think I'm doing a bad job explaining. Do you have any questions? Like, here's the deal. Like, you ask as many questions as possible. Like, if you're not asking questions, then you're not gonna learn. So make sure you ask as many questions. Even if it's this question like, why do we have a variable called I? Why can't we call it Neil? Why can't we call it Bob? Why can't we call it like Harry Potter? You can ask those questions. Those are valid questions. Just make sure you ask questions, because if you don't, you won't gain that little thread of insight that'll allow you to execute in the future. Yeah, probably like after this class. That's when these notes will be available. So this is basically what's happening, right? So I equals 0, and then for every iteration, it goes to the J loop, right? Any more questions, or? Okay, I think I'll get into it then. So if you want to print out this pattern here, we want to do two things. We want to control each line, and we want to control the movement to the next line. Does that make sense? So we want to print the number of stars. So here's how you can look at it. You can say the outer loop is for controlling the number of rows, right? So we have 1, 2, 3, 4, 5. So this outer loop, oh, it's a bad way to do it. We can say the outer loop is for controlling the number of rows. The inner loop is for controlling the number of stars on each row. Do you guys kind of get that? Like in this case, you have two moving parts. You have the number of rows and you have the number of things in each row. When you use a single for loop, you only have one moving part, which is you want to print something a certain number of times. It's very simple. When you're trying to control two different things at the same time, it's best to use nested for loops. So does that make sense to everybody? For each run of the outer loop, run the inner loop. For each run of the inner loop, do the thing. Yep, that's exactly right. That's perfect, Paladin. That's what I was trying to kind of explain. Yeah. So let me show you guys kind of how this works. So on every single run, I want you guys to guess what this will print. I want to make sure you understand this before I go into the star printing pattern. So drop a guess on what this will print. I'll put the code in the chat to make it easier. Okay, it's a little messy, but let's see. Yeah, what do you guys think that will print? He said it'll print out 0, 0, 0, 0, 1, 1, 1, 1, 2, 2, 2, 2, whatever. Yeah, you're exactly right, dude. Yeah, that's perfect. Urban, you get a cookie for I'll actually remember, like, next class I'll keep track of who all is answering. Urban, yeah, perfect, dude. Oh, that's awesome. So yeah, that's what happens because let's think about it, right? So I equals 0, I is less than 5. I mean 0 is less than 5. We execute the body of the inside loop. J equals 0, 0 is less than 5. We print out I. Increment by 1. 1 is less than 5, we print out I. 2 is less than 5, we print out I. 3 is less than 5, we print out I. 4 is less than 5, we print out I. This loop terminates once we hit 5 because 5 is not less than 5, so we go back to the outer loop. We increment I by 1, so I equals 1. 1 is less than 5. We go to the inner loop. J equals 0, yes, print out I. J equals 1, print out I. J equals 2, print out I. J equals 3, print out I. J equals 4, print out I. J equals 5? Nope, we don't print out I. This loop is done. We go back to the top. Now I equals 2. Is 2 less than 5? Yes, so we do the inner loop. Do you guys kind of get that? So it's you do the inner loop on the outside, and then you do the inner loop's kind of like the yeah, I really hope you guys get it because it's just like saying for each iteration of the outer loop, you do the inner loop to completion. To each iteration of the outer loop, you do the inner loop to completion. That's an important thing to remember. So now let's try printing out the star pattern. So the outer loop controls the number of rows, and the inner loop controls how many stars are going to be in each row. So does anybody have any ideas on how to do that? It looks like Basti.dmn has a good idea of what on how to print out the star pattern. Oh, she stopped typing. I guess that's a little depressing, but I think I'll walk over it to make sure you guys understand. So basically the outer loop controls how many rows. So how many rows do we have? We have 1, 2, 3, 4, 5 rows. So let's do that. We have 1, 2, 3, 4, 5 rows. The inner loop, we want to print out how many stars. So we always want this to be less than I, right? So when I is 1, it'll print out 1 star. When I is 2, it'll print out 2 stars. When I is 3, it'll print out 3 stars. When I is 4, it'll print out 4 stars. When I is 5, it'll print out 5 stars. And remember, at the end of it, you want to go to a new line. So let's see what this does. Cool. Oh wait, whoopsies. Oh yeah, that's true, of course. I want to start there, right? And then I want it in quotes. Okay. Nice. So this is the star pattern we intended, right? Right. That's an important. I forgot to mention that. Yeah, J gets reinitialized when the control reaches when the control goes inside for the first time after incrementing the I variable. Yeah. Nice. So this is kind of what happens there. Now let's talk about while loops a little bit. Okay. Okay. So I hope you all got all this down. We're going to talk about while loops. So all while loops are saying is while a certain condition is true, keep doing the body. It's much simpler than for loop, trust me. So if I say in I equals 0, while I is less than 5, while I is less than 5, I plus plus, and on each execution, I want to print out Neil. What do you guys think this will print? The while loop. Anyone have any guesses? Oatmeal Man says Neil. Okay, he thinks he'll print out 5 Neils. First thing you want to do is you want to trace through the loop. So you want to say in I equals 0. Is 0 less than 5? Yes. So it prints out Neil. I becomes 1. Is 1 less than 5? Yes. It prints out Neil. 2. Yes. 3. Yes. 4. Yes. So, Oatmeal Man, yes, you are correct. Good stuff, dude. Who's the other one? Oh yeah, Urban got it right last time. This time, Oatmeal Man got it right. Cool. So, yep, you're right. Now let me ask a little bit of a trick question. What would happen if what would happen if I did this? I want you guys, do you guys have any guesses? How, would it be different from the other execution, or would it be the same? He said no. So no, it wouldn't be the same, or no, it would. It would be the same. It would be the same. No, actually, it wouldn't be the same because. So let's walk through it. So I equals 0. 0 is less than 5. That's true. I equals 1. You print out Neil. Is 1 less than 5? Yes. So you increment by 1, you get 2. Print out Neil. 2 is less than 5. You increment by 1, you get 3. You print out Neil. 4, you print out Neil. Oh yeah, so it might be the same. Let's see. Yeah, it is the same. Correct. Good job, guys. So, next we're going to talk about do-while loops. So, this time, instead of going over, instead of waiting to check the condition, we're going to first do the loop body and then check the condition. So it says here, do while first enters a loop body and then checks the condition. It doesn't wait to check the condition. So here's an easy example explaining that. So if I say in I equals 60, and I say while I is less than 59, right? Print out Bob, right? This is not going to work. This is not going to run at all, right? Because 60 is not less than 59. But pretend we have a do while loop, right? So pretend we say int I equals 60, while I is less than 59, print out I. Pretend we had this, right? This would print out 61 exactly one time, even though our condition is not true. The do while loop ensures that you execute the loop body at least one time. Does that make sense? Yeah, so it'll just do it one time. Okay, cool. Um, okay, so for homework, I will give you guys to the option to print these two, but I'll talk about the switch break statement real quick. The switch statement real quick. So in Java, there's something called switch statements, and switch statements allow you to cycle through a number of cases. So I think I'll use the example he gave here. Yeah. Okay. So in this case, we're initializing a character which remembers 2 bytes called letter, and depending on the value of the letter, we're going to check if it's a vowel. So here's how it works. We find the case that corresponds with our variable, and we execute down from there. So car letter equals B. Is it A? Nope. Is it E? Nope. Is it I? Nope. Is it O? Nope. Is it U? Nope. So it goes to the default and it prints out consonant. So here's another way to do that actually. You could also do, so it's basically, depending on the variable value, it prints out the case that corresponds to it. So I'll show you another one. So yeah, so you can use letter grades, right? Like pretend you have certain standards for your grades. You can define those standards using a switch statement. So depending on your grade, case A, println excellent. Case B, println very good. C, good. D, satisfactory. E, not good. And by default, if none of these are true, then it fails. So one thing to remember is to keep a break statement. So what a break statement does is it prevents the condition from cascading through all of them. So pretend I didn't have the break statement, right? Pretend I just took out all the break statements, and my grade was A. In this case, it would print out excellent, and it would print out very good, because it wouldn't break. So let's see what happens. Yeah, see? So it prints out excellent, very good, and then good before breaking here. So we have to keep our break statements if we want to limit the output to one case, which in most cases we want to. Except in the vowel, you saw that there were multiple cases which you're going to hold true, in which case you don't want to break. Yeah, so I'm going to talk a little bit about break and continue statements a little bit more because I think those might be a bit confusing, but that's the basic logic behind switch statements. Don't worry if you can't memorize all the syntax, you can Google this stuff easily. Just understand the concept. So break allows you to exit out of loops. So pretend I make a while loop, which is here, and I say while I is less than 10, I plus plus, system.out.println, So pretend I have this case, right? And I want to break when my value reaches 5. I don't want to execute anymore when my value reaches 5. So I say if I equals 5, I want to break. So what do you guys think this will print out? Neil times 5, yeah. Yeah, basically, yeah. Yep, because at I equals 5 it breaks. Now let's talk about a continue statement. So, okay, so our continue statement says you skip whatever's on the bottom and you automatically go back to the loop execution. So you automatically jump back up to the while statement when you see the word continue. So let's see what this prints. Okay, so do you see how this, around I equals 5, it skipped over this, and it went back up. So, I have an idea. So let's say, like, skip me. Cool. Wait. So this says, for every other value except the first value, um, is going to skip over what I skipped. So only in the case of I equals 1 will it not skip. Yeah, that makes sense. So what continue does, it basically it brings it back up to the top. That's what the continue keyword does. Okay, nice. Um, so for homework, you guys are going to be doing these two patterns. So I hope this lecture wasn't completely boring. It's definitely a little bit less attendance than last time for sure, because I think last time we had like, I think we even had like 30 people at one point. Um, but yeah, my Wi-Fi just went out. I'm sorry. But yeah. So if you guys have any questions, feel free to DM me or feel free to ask on this chat. I'm always there to help. And yeah, um, hope you all have a good day. I'll see you later.